All right, so we're going to look at question 21 from our little review packet here. We're just finding the domain of several of these functions. So remember, the domain is the numbers that you are allowed to plug in for x, and you can never take the square root of a negative, right? So this stuff underneath the radical, I just need to take that 9 minus 2x, and I need to make sure that it's positive. What I do is I set it greater than or equal to 0, and then you just solve this inequality. Okay. Move the 9 over, and that's going to give you negative 2x is greater than or equal to negative 9. And then you'll divide by negative 2. Okay. And since you divided by a negative, you're going to flip that inequality symbol. It'll be x is less than or equal to 4.5. Okay. Which would be the same as negative infinity up to 4.5 if you were doing it in the interval notation. All right, so what this means is that as long as you plug in a number that is less than 4.5, you're golden. All right. If you plug in a number like 5 or 6, you're going to run into problems. Like if I plug in 6, you would get 2 times 6 is 12, and then 9 minus 12 would be a negative, and you can't take the square root of a negative. Right? Number 22, you got 2 things that you have to worry about on number 22. You cannot take the square root of a negative. So that part that's underneath the radical, all right, x has to be positive. So I know that x has to be greater than or equal to 0. It's got to be positive. The other thing that you have to worry about is you cannot plug in any number that would cause the denominator to equal 0, because you're not allowed to divide by 0. All right. So if we want to figure out what that is, like if you actually want to figure it out algebraically, you might be able to tell what number to avoid already. But, you do square root of x minus 3, and you set this equal to 0. This is going to tell you the one number that x cannot equal. Add 3 to both sides, and then you would square both sides, which is going to give you a 9. All right, it would tell you x is equal to 9. This is the one number you want to avoid, because if you take the square root of 9, you get 3, and then 3 minus 3 would be 0. And you cannot divide by 0. All right, so the domain of this function is going to be all numbers greater than or equal to 0 because of that, but x cannot equal the number 9. If we wanted to, another way that you might see the answer choices for something like this would be on a number line. Okay, so they might have a little number line that you have to graph, or that you have to match the graph to. It would go something like this. It would be a closed dot at 0, going to the right, but once it gets to the number 9 right here, they would have an open dot at the number 9, just signifying that you have to skip that one number, and then it would continue going forever to the right. Okay, so this right here would represent the domain of this function. All numbers bigger than 0, but you cannot pick the number 9. Okay. 23, let's see. The numbers have to be, hopefully you can tell from here what number that you cannot plug in for x. Like x cannot be a big negative number, like negative 10 or negative 9, because that would cause a negative under the square root. Now the top part on this x plus 4, it absolutely does not matter what you plug in for x right there. All right? There's no domain restrictions for the top part. X can be whatever number that it wants to be. So I'm going to take this x plus 8, and I just need to make sure that that is positive. I'm going to set it strictly greater than 0 this time because you cannot have it equal 0. So I don't include the little bar. That would cause a division by 0. Minus 8 from both sides, and you got it. X is greater than or equal to negative 8. And that's going to be the domain there. In interval notation, that would be negative 8 to infinity, and you'd put parentheses around both sides because you're not including the number negative 8, and you can't include infinity because it's too big. It's non-includable. All right, that'll be good for this video.